Welcome to Homework Lib.
So this question wants us to examine how much distance is allowed for sodium chloride. So we know that when two atoms are very close together, they do not carry as much potential energy, electric potential energy. But then when they are further apart, they carry more potential energy. And then when the potential energy is large enough, those atoms would prefer to just stay isolated compared to when they are bonded. So if we want to find the critical value, what is threshold energy? The threshold energy happens when the energy of atoms separated, that is, sodium atom and chloride atom. So separated atom has the same energy as bonded atom. Bonded atom, we have sodium, but not as an atom, but as an ion. So sodium plus, and we know that ions have lower energy than atoms. That's why they like to bind together in nature. Chloride negative ion plus the potential energy of separating. So this when they're about to separate, the threshold value, the critical value is when we take an equal sign over here. And then usually these two values, if this value is larger, they prefer to stay as separate atoms. If this value is right hand is larger, then they prefer to bind together. So this gives us, because all the values of atoms and ions are things that we can just look up. So the only thing we do not know is this function. This function is the potential, and we can find it as a function of the radiance, because the potential energy is -1 over 4 pi epsilon naught E squared over R. So this is just the equation for electric potential energy. It's dependent onto the charge of each atom, which in this case is just E, and then it's dependent onto their separation. So if we want to find the separation such that the maximum separation is when this equation takes the equal sign, and that gives us the maximum potential energy. And this maximum potential energy gives us the maximum distance between the two atoms. So let's find it. Radius, if we rewrite the equation, is 1 over 4 pi epsilon naught E squared over negative UR. So 1 over 4 pi epsilon naught, this is actually a number we know. It's just 8.988 times 10 to the 9th Newton times meter square over c squared. This is just a constant 1 over 4 pi epsilon naught. Sometimes we also call this k. And then E squared is 1.6 times 10 to the negative 19 coulomb squared over negative U. So what is U? U is equal to energy of sodium plus energy over chloride minus energy of sodium ion minus energy of sodium chloride. So what is that? That is just the ionization energy of sodium in the ionization energy of chloride. The ionization energy of sodium is 5.1 electron-volt, but here we are removing an electron from sodium, so it's negative 5.1. And then the ionization of chloride is getting an ion, so the ionization energy is 3.6 electron-volt. Oh, I don't need this extra. Yep. All right, so we enter everything into the calculator. We have everything in terms of, this is negative 1.5 electron volt. It might be easier in terms of joule. So anyway, if we enter everything into the calculator using the SI units, we will get a radius of 0.96 nanometer. So that will be the maximum separation between the two atoms. If the separation is any larger, this molecule will break apart. So that is for part A, for sodium chloride. For part B, it asks us to refer to another question and to find the separation of a different molecule. And that molecule is, let's see what that molecule is. It is potassium bromide. Okay, so everything's the same except that now we need to use ionization energy of two different atoms. We need to use ionization of potassium and potassium plus, and the ionization of bromide. Bromide is losing the atom. So ionization of potassium, if we look it up, is 4.3 electrovolts. And then the ionization, or it's not really ionization. Protein, it's not a metal. We should probably call it electron affinity. It's 3.5 electrovolts. Okay, electron affinity of bromide is 3.5, so that gives us U equals negative 4.3 electrovolts plus positive 3.5 electrovolts. It is equal to negative 0.8 electrovolts. Okay, all the rest of the steps are the same. We use the same equation for R, except that now we have a different energy. And the charge carried by each atom is still E squared, and now we have 0.8 electrovolts. And again, let's use 1.6 times, let's use SI units to convert this into joule. And turns out the final answer we get is 1.8 nanometer. This is a maximum separation between the two elements, which is twice as large compared to the sodium chloride.